Hey, welcome to the UI5 TypeScript tutorial. If you know how to do application development with UI5, but you want to learn how to do it in TypeScript, then this is exactly the right video for you. I'm Andreas Kunz, one of the lead architects in the UI5 development team at SAP. And together with Peter Müßig, the chief architect, I have prepared a workshop for TypeScript development of UI5 applications for the UI5Con 2023 conference. And as those were not recorded, we are now, preparing a recording for you, so you can still watch it if you have not attended the conference. You don't need to know anything about TypeScript for following this tutorial. You should know something about UI5 development, because we're not explaining the basics here. And if you know something about TypeScript already, some of the parts will be known to you. But then again, there are other parts that will not, so it's definitely still worth watching. So, first I'll give you a short intro to TypeScript itself, like 5 or 6 minutes. Just a short recap to get everyone on the same level, and then we'll dive right into the tutorial and go through the steps. I'll do the exercises here. You can follow along or just watch, whatever you want. And this tutorial will first create a simple application from a template, so you get easily started with the entire setup. Then we will do some basic development tasks in applications and see how TypeScript helps. And later on, we will go into more advanced topics like control development and using third-party libraries and testing and so on. So a very quick TypeScript intro. TypeScript is basically JavaScript plus some type information. So if you see it on the right here, the white stuff is mostly JavaScript, so var, some number, and the blue stuff is the type annotation that tells the TypeScript compiler what types certain things like these variables have. So the first variable is obviously a number, as it is assigned like this, and TypeScript will prevent you from putting a string there or doing string operations on it and so on. The second line, it's also a number, and TypeScript automatically knows without you writing it because a number is assigned. Then TypeScript automatically types the variable as a number. Of course, that's not the only place. You can, for example, assign types in function parameters, and you can do more complex stuff like defining structures and much more generics and whatever. So there's a lot you can also do with TypeScript, but the most things you will do during normal application development is, I think, exactly what you see here. Simple type assignment, some basic structures. TypeScript is something that the browsers do not execute, so it's something that needs to be transpiled to regular JavaScript. It's only something that is relevant at development time in your editor and helps you there. For JavaScript libraries like UI5, there can be so-called DTS files, the type definition files that describe the API of those JavaScript libraries in terms that the TypeScript compiler understands. For UI5, we are generating them and publishing them at npm as types/OpenUI5, where definitely typed, or as sub-UI5 types and OpenUI5 types. That's something we release directly. Some special things are that we are providing these type definitions in a way that more or less forces you to write modern JavaScript. And that's a good thing, this force, I would say. So modern JavaScript means ES6 modules and module imports and ES6 class definitions. So this is how you write your TypeScript code in very modern JavaScript and TypeScript. And this is also, while there's anyway transpilation, it's also transpiled to the regular UI5 calls. And you will see this in a minute, so you will understand it, I think. The benefits of TypeScript are that in the editor, while you are coding, you immediately see many of the errors you would otherwise only notice at runtime. The editor, as it knows the type of everything, can suggest code completion for methods and properties and so on. You can see the documentation of the APIs right inside the editor without switching to the UI5 demo kit or so to look up the API documentation. And of course, it helps with refactoring and maintenance. When people later on look at your code, or you look at your old code and want to understand what everything is, then it helps a lot when everything is typed and well defined. And some of these benefits you will notice right away in the course, and some of these come later on as you maintain and extend TypeScript code. So what I just mentioned, this transpilation from TypeScript to JavaScript, and also this transformation of modern JavaScript into the traditional UI5 calls is depicted here. So you have a web app folder. If you remember an earlier UI5 setup, there was a source folder and transpilation to web app folder, and then the UI5 build. This has been simplified now. So since June 2023, more or less, or a bit earlier. That's just the web app folder where you have the TypeScript sources. And then inside the UI5 build tools in the UI5 tooling transpile, middleware and task, there under the hood, the transpilation from TypeScript to JavaScript, and also this modern JavaScript to traditional UI5 code is happening. So it's happening all under the hood. Of course, you get source maps generated, so you can debug the TypeScript code inside the browser as if it would be the code that the browser executes. So that was all for TypeScript introduction. Of course, there's on the official TypeScript language website, for example, there are more introduction pages and documentation and everything. But I think for the time being, that's enough. So let's head right into the tutorial. The instructions can be found on github.com, sap-samples, UI5 TypeScript tutorial. And this is where we are going now. So this is the page you will enter when you enter this URL. It gives you a short introduction into the tutorial itself, like what you're going to do, what I have already mentioned, and explains what this app is about. So we are developing a very, very, very simple weather app. We are really not focusing on creating a cool app that is shiny and impresses people, but on something where you really learn all the important things about TypeScript development. And the things you have to have is a current version of Node.js. We are doing it with Node 18 here. And a code editor, I'm using Microsoft Visual Studio Code. So this one and many others for sure supports TypeScript development very well. So you can click through from your code to the definitions of the UI5 classes, browse them and so on. And it has all the features that you need for TypeScript development. And yeah, I think if you have these preconditions, you can right away click the first link, exercise 0, get prepared, to get started with your setup for development of TypeScript applications. So what we are using here is Yeoman. That's a very popular template generator where you can get started with the foundation of an application very easily. And for this Yeoman, we have a generator called EasyUI5. This is like a collection of UI5 application and UI5 library templates that we are using now. And the first thing you have to do is now typing this into your command line, npm install -g, so to have it globally. That's the Yeoman generator, and then the EasyUI5 generator. So install both things. I have done this already, so I won't do this again. But once you have done it, you can check whether the generator has been installed successfully by listing the generators. And EasyUI5 needs to be listed, obviously. And it should be the version at least 3.6.2, so everything is working well. So it's here, the version is also right, I'm sure. And now you're ready to really start creating the TypeScript application. So that's why we head to exercise 1. So here in exercise 1, we really use the EasyUI5 generator with a TypeScript application template to create the full setup for a TypeScript application. Normally for a productive application, you would just say, EasyUI5 TS app to get the most updated version of the template. And this will probably deviate from the tutorial that we don't want to update all the time. So we have a copy of this template that is currently current. And for the TypeScript tutorial, just to follow along, you should use this one. For productive applications, use the real up-to-date template. So we go to some directory of our choice and paste this command, and we will be greeted by the Yeoman template generator, and it will ask us a couple of questions. The application namespace, we can just accept the default. OpenUI5 is enough for this tutorial. And now it checks what the current version is of the framework and of the types. And 116.0 is the current version right now. For you, it might be a different one if you follow this tutorial later. The name of the application, of the author is fine. I want to create a new directory, and local Git repository is okay. And now everything has been set up. So all the files have been created, and the folder named like the namespace we just chose is also ready. So you can change there and open Visual Studio Code by entering code. All right, so now we have a look at this application stub that has been generated. So we have the web app folder, as I explained, where all the resources are. You know that, set up with a view and controller folder with an index.html page for starting it standalone. The only difference is that these resources are in TypeScript now, not in JavaScript. And outside this web app folder, you see there is some linting configuration, some tests configuration. We will come to this later. And also the tsconfig file, which defines how TypeScript interprets the code and where to find the things, and certain rules are enabled or disabled. So this is basically the TypeScript setup here. So if we go to the web app folder, we see the original code, the TypeScript code. And here is what I mentioned earlier. That's now here not TypeScript, that's modern JavaScript. That's ES6 modules that are imported. The dependencies are imported. And this here is the definition of an ES6 class. So it's not UI component.extend, like in UI5 you usually write it, but it's a JavaScript class definition basically. And when we, for example, build this and run build, when we build this application, then we'll have a look at the output, the transpiled output, and then we'll see that in the dist folder where we have just the same file, let's pick the debug version, that we have no longer these module imports, but we have a sub-UI define statement here that requires the modules. And this is it's still required by UI5 to have the modules imported in this way to do certain things. Also, the class definition is now UI component extend. So that's the two things where modern JavaScript is used in TypeScript applications, but while the TypeScript is transpiled, also those constructs are changed to the calls that UI5 requires. Apart from that, the code looks pretty much the same, so it's not like some cryptic compiled stuff, but the comments are there in the debug version. It's nicely indented and so on, so you can still read the code, and the difference is actually not so big to the original component TypeScript file, so that's just the same code. Actually, there's not a lot of TypeScript in this code, so if you see here, this is modern JavaScript, this is JavaScript, this here is TypeScript, so this class variable gets a string type assigned. And the return type of the init method and also of the content density class method, this is also a piece of TypeScript that will not be there any longer at runtime. But I think the rest of the file is entirely pure JavaScript. So this shows you that TypeScript is not so different, a completely different language. It's just some pieces on top, right? Okay. What else? So one thing, if you have used TypeScript already for UI5 development, then you should be aware that the types are no longer, so the types recommended are no longer called ts-types-esm, but they are now have been renamed to UI5 types, and the other name is deprecated. You should not use this any longer. The content is the same. Okay. Also, if you have used it earlier, you might have used the device class from sub-UI device in a bit different way. So you had named imports from the subparts of device. This has been changed in 1.115 or so, about that. Yeah. What you can see here is, for example, what's popping up is the inline documentation. So no need to go anymore to the demo kit of UI5 to browse the API documentation, but you see it right there inside the code. And what you can also do with Control-click or on a Mac Command-click, you can jump right to the definitions inside the UI5 DTS file. So that's the ones I have mentioned earlier, where we create the information about the UI5 APIs in a TypeScript way. So there's the module sub-UI device declared with the interface device inside, and then you have what you call sub-UI device browser and support and so on, and system, which are then defined later on with the content, where you can check the device type and so on. But basically this shows you how you can drill down into the definitions of everything and follow along and read the documentation. Okay, let's close these files. More of the TypeScript benefits can be seen later. So let's go to the tutorial and see what we now do in this application. Well, we are still in exercise 1, which said, okay, open VS Code. We saw the structure of the application. And yeah, one thing you can definitely do is, of course, start the application. The npm start command uses, as I said, under the hood, the UI5 tooling transpile to transpile the TypeScript files to JavaScript on the fly and serve them then to the browser where you can check your development. So if you open a terminal here inside VS Code with new terminal, then you can, or do it in your standard terminal, you can say npm start. This starts this development server in a kind of watch mode, so everything you modify in your source code will then be reflected here in the web page. So that's basically the very simple template result of the application, just a button on a page that's greeting you. And if I open the development tools, let's zoom in a bit. I can also show you how we can debug in the TypeScript file. So if we go to the main controller and set a breakpoint, for example, in the say hello method, you see that's still the TypeScript code, and the modern JavaScript, that's not actually what's executed. The executed code is this here, but there are type maps provided which tell the browser, okay, every statement here belongs to a certain statement in the TypeScript. So for us, for easier debugging, the browser can display it in this way. You can just set a breakpoint here in this method handler, and you can inspect everything. So you can really debug your TypeScript code, basically. And whatever you change in the application will reflect right here. Let's see whether we have here the hello button. If you just change the text to something else and save, then this is immediately reloaded in the browser automatically. You don't need to do this, and now it's the button says hi. All right. The only situation where you need to restart this npm start thing is when you change the configuration of the UI5 build tools themselves. So when you do that, we will come to such places, then you will just have to restart it. Okay, now let's get to exercise 2. So this is now exercise 2. The first parts are about understanding the code and how TypeScript helps. And this is actually something I've already shown to you. Saying more or less the same things that I said. Now let's start really with coding. The first thing we want to do is create a model. So as I said, we want to create a simple weather app, and the weather data is going into the model and then displayed in the UI. So to create this model, we implement the onInit method in the main controller, and we don't want this button say hello thing anymore. So what we're going to do is go to the controller folder, web app controller, don't go to dist, web app controller, main controller, and delete the say hello method. And instead we want to create the onInit method. And when I don't remember, is it onInit or is it init? Or how's it in controls and in components and controllers might be different. Just type ini and TypeScript knows the things that are possible and suggests onInit. So you can just pick it from the list or press enter. And you get the entire method body generated. So you need to press less keys. You save time already when just writing something. And it also tells you what you can do in this with this method. So everything at your fingertips, so to say. And to create this model, we say const model. And in this case, I would suggest you really type it. Later on, you can just copy and paste to make it easier. But here, if you type it, you see the benefits better. So new. And if you just type J, JSON model is already almost at the top of the list. Just pick it from a list. And this will not only write the entire word, but will also add the import at the top of the file. So you don't even need to write those imports. So if you think back to go to the sub-UI define or sub-UI require all the time to enter the things you need and then to use it again below, this is now happening all automatically. So this helps a lot. So we want a new JSON model and want to set the model on the controller. So JSON model, this dot set model. I also don't type it again, and here even the entire rest is suggested by some AI feature. So I can press whatever. Yeah, just press tab and everything is there. So the model is set. That's this part. Now the second thing we want to do is to actually load weather data. And there's a service called OpenMeteo, which is a free service for weather data, and we are using this one. To do so, we just copy this load weather data method and add it after the onInit method. And some parts might or might not look a bit unfamiliar to you. For example, this here. This is pure JavaScript. It's just a parameter initializer, so a default value for the parameter if nothing is given. Another thing is the async and await. Again, plain JavaScript. That's how you write asynchronous JavaScript in a more readable way than using promises or callbacks. The fetch here is also a new API in JavaScript that makes fetching HTTP resources easier. And one more thing that might look unfamiliar to those not up to date with the most current JavaScript. This is here a template string, again plain JavaScript, where just avoid writing string plus variable plus string plus variable plus string and so on. So you can have these placeholders here in template strings. That makes string concatenation a bit easier. So basically what I'm saying is there's zero TypeScript in this. This is all just JavaScript. So, and if you just have a look at what this request will return, then zoom in a bit. Basically, if you give a latitude and a longitude and just ask for the current weather, then this is what you get. You get the actual latitude and longitude of the weather station, and some meta information, but most importantly, the current temperature, wind speed, wind direction, and a sort of weather code that tells you that's a list of certain weather kinds, tells you what the weather is like. And this is basically the structure we will put into the JSON model. So this is what we're doing here. We get the model and set the data. And finally, we need to call this method. We want to show some initial weather from these coordinates which relate to Waldorf. So initially, we just load weather data without parameters, and we get the Waldorf coordinates and the weather from Waldorf. So even though there's still a TypeScript error displayed, it already works. So if we go back to the application, which is somewhere here, well, we have to adapt the view first. Let's come to that later. Let's first solve this error. So what TypeScript says here is that the property set data does not exist on type model, and that's true because get model returns the base type model of UI5. It doesn't really know whether it's a JSON model or an OData model. There are ways to work around this, but for now, as we want to learn about TypeScript, we learn how typecast works. So you can do typecast in two ways. You can write something as, and then the type behind that, or you can cast it with those arrow kind of brackets in front of the thing you want to cast. I prefer this method because the other one looks a bit like generics. So if you assert to TypeScript that the model is a JSON model, then it knows, yeah, JSON model has a set data function, so this is fine, and the error is gone. There are also some linting errors, so I have not talked about that. I'll open a new terminal here. If we run npm run lint, linting is a sort of code check. It checks for code smells and for potential errors and so on. And this is all already set up here with the TypeScript linting settings. And it will find things that might be problems that TypeScript doesn't catch. So what we have here, a warning that message box is defined but never used. That's true. The message box we had in the original code for the pop-up. We don't need that. And then that's a bit a strange thing. Promises must be awaited. That's about this line. So the load weather data method is asynchronous, and this means it returns a result later on. And to ESLint, this sounds a bit fishy that you call a method but don't even handle the result, which comes later after the onInit method has already been completed. So one way, the suggested way to solve this problem is to assert that we don't want to do anything with the result, to write void in front of it. And actually void is a JavaScript construct that I have personally never used. You might not know it, but that's how we can deal with this error here. And then we have two other things: the unsafe assignment of an any value. And this is the problem here. So the response of this weather API call, when we transform this to JSON, the call doesn't know what the structure is that is returned, right? So it has type any, and any in TypeScript means no type safety at all. And everything I do on such an any value will also be type any. So it's like falling back to JavaScript. And this continues on and on as you work with these things. So we don't want that. And the ESLint check here also says, no, that's not something we want. So what we can do here is define how the structure like. So that's again a learning for TypeScript. You can define your own types and your own structures that you use inside your code. Let's just put this thing, this type weather info. somewhere, for example, to the beginning of the file. Of course, in a big project, you would have your separate types folder where you define your own types that you're using across the application. But for simplicity, we can do it like this. So we define a new type for TypeScript that we call weather info. And the structure is an object with one property called current weather, which again is an object that has temperature, wind speed, and wind direction as numbers. This is basically reflecting the interesting parts of the API response. And now we can use this name weather info and do again a typecast here. So we say, well, the response that is coming back here, the JSON, is a weather info. And once we do this, TypeScript says, okay, then JSON data is apparently a weather info. And we could now say JSON data dot current weather dot temperature. So you get the code completion also for these things. You type yourself, of course. We don't need this here because we use the model binding for getting the data into the UI. So if you run the linting again, run lint, no errors anymore, so the linting is also happy. So now we have fetched the data and put it into the model. Now we also want to display it. So we go to the view. That's in view.main view XML. And we get rid of this message page we had earlier that was having this say hello button. And we are pasting a sub page with a simple form as content that has 3 fields, a temperature field, wind speed field, and wind direction field. So just 3 texts inside a form. And because we have used now this new form namespace inside the layout library, we have to add a new XML namespace to make this known. And in the end, the view should look like this. And should be done. Now also the UI5 tooling needs to know about this new library. So it can load and prepare it. So this is why we go to the UI5.yaml file and the UI5 dist.yaml file. And in the list of libraries, that is somewhere here, just insert this layout library, which we had not used before, apparently. Oops. So. And also in the manifest JSON, which I don't think is used right now, but to be complete, in the manifest JSON, there's also somewhere in the middle, I think, there's a list, yeah, there's a list of dependencies of the libraries that are used inside the sub.ui5 section, dependencies, libs. And just enter this section, don't forget the comma. Yep, oh, it's good. And just a hint, when something doesn't work, the first thing you should check whether you have saved all your changes, because this is, as stupid as it sounds, it is the most frequent cause of issues when following such a tutorial. Okay, now we are done with this exercise 2. So if you still have the npm start task running, then you have to restart it because we have just changed the UI5 configuration. Oh, that was the wrong one. Just npm start. And browser will open automatically in a second. Yep. This old one. And here you have it. I'll zoom in a bit. So we have now this new page we have configured displaying the current weather with a temperature 20 degrees, pretty slow wind, and the wind direction is 298 degrees, whatever that means. We will come to that later because we will visualize this with an arrow pointing in the direction. Okay, so this was exercise 2 with some application development. Let's go on to exercise 3. In exercise 3, we want to react to some user input because just displaying the weather of Waldorf is a bit boring. Let's have the user enter some location for which the weather should be queried. And the first thing to do is to extend the UI here. We'll add another input into the main view. I'll close some of those files that we don't need any longer. So above the simple form, inside the page content, so content input form, paste this input. The sub input calls a location change method inside the controller when changed, and by default it shows enter location as a placeholder. In this tutorial we also don't bother with translated text and so on. This is standard UI5 stuff. It's important, but it's not important for learning TypeScript. So this is why we just ignore translation right now. It doesn't make a difference in TypeScript. And as we have from an entered location, we have to first find out what are the geographic coordinates. We are using another service. Actually, the weather service could also do it, but we want to learn more. So we are using a different service. And this service, if we enter a frequent place name like Newtown or so, then we want to make sure that we found the correct one, the one we actually intended. So we get from the response of the service, we get also again a place name. That's the one that the service has found, and we want to display it so you see which Newtown this actually relates to. So this is why on top of the form, inside the form this time, we enter another field with a label place, and the text is bound to place name. We'll come to that later. Right now there's no place name inside the model structure, but we'll add it. So now we want to react on this input field. So when the user has entered something, then we want to get, okay, what has the user entered? And later on send a request to this other service to find out what the coordinates are. So somewhere in the controller, in the main controller, we add this location change method here. And what you see here is again a TypeScript error. So TypeScript tells you that the parameter if event implicitly has an any type. That's again this any type. That means, well, it's made plain JavaScript, and whatever you do with it will also be any. So event is any, get parameters is any, the value is any. So you basically lose all the code completion, all the type safety and so on. And so this is why you don't really want to have that. And when writing TypeScript applications, like typing the parameters of methods, also when converting from JavaScript, typing the parameters of methods is one of the places where you really often do TypeScript stuff. All the other code, as I said before, is mostly JavaScript actually. And yeah, for events we have since UI5 1.115, I think, we have specific event types. So each event knows exactly about the parameters that the event contains and so on. And the event name is composed as the control name. It might be a base class, like here for the input, the event is actually defined on the base class input base. Then a $name, a dollar character, and then the name of the event plus event. Yeah. So it's the change event in the input base. And this is how these names are built. Yeah, what I've not shown so far is the quick fix feature. So when you have entered something, you can, and it shows an error. Sometimes there's a quick fix help that says, okay, input based change event, it's not been imported so far. When I click quick fix, then I get the suggestion that I can let the editor add the import on its own. So I just click add import for sub-m input base. And now the import, named import here, is automatically added. So you'll rarely find yourself adding any imports manually. That's all happening with such tools. And this input-based change event means that the IDE now knows exactly what the parameters are that are available. So it only has a value parameter, this input-based change event. Also, if you use the getParameter function, where you just put strings in, early on you could put in any string and there would just nothing come back. And now there's also a list of the actual values. So if you mistype like value or so, then it's apparent to TypeScript, well, value with the uppercase, first letter doesn't exist. Also value doesn't exist, only value is a legal value, and then it confirms, yeah, that's correct. And also types the result correctly, because as I said, the events in UI5 are fully typed, and so you get type safety also for the event parameters. There's one thing you could accidentally do in a wrong way. So there's an input change event in the sub web components input control. So don't pick this one accidentally. This could happen when you start typing here and only know, well, input, change. So you don't need to type it in the correct order, even when you omit the dollar. Some of the possible completions will already be suggested. And the first one is actually the one in the web components here. So don't pick this one. Make sure it's the input-based change event, which is this one here. So you can check from which type it's taken. So or from which module. So you should be able to pick the right one here. So there's one more thing, a bit advanced maybe. I just copy over the entire thing. So for event handlers, for stuff in XML views, it's most efficient to write it like this. You can, of course, dynamically assign event handlers to something. So this is doing the same thing as we did below, so we have to remove it later on. But just to show you some further things, we can acquire dynamically the input, which has the ID location. That's the ID location. And by ID returns just an UI5 element. So it doesn't know what ID belongs to which type of element. This is something that's missing in TypeScript. TypeScript doesn't know the UI5 XML views. So our by ID just returns the UI5 element. And you could do some casting. You could also use something called a type guard. And a type guard here is, for example, built into our UI5 is a function which checks whether something is of a certain type. And we have extended this one so TypeScript also understands what we are checking here and later on automatically knows what it is without explicit casting. So if we do the quick fix for this input, so we want a sub-m input. The import is added at the top. So if you want, if you write such a condition here, then inside TypeScript knows this is a sub-m input. It's not an explicit cast, but it's called a type guard. And here, if we call the attach change method on the input, then the event you don't even have to type because it's built in, so to say, to this attach change method. that the parameter of the callback function is an input-based change event. So here you don't get this error, is type any, and you have to write the type. Here it's happening automatically. But as I said, we don't need to register to this event dynamically. We can just use the location change method, which is registered here for the change event. Okay, now this was exercise 3. So if we go back to the application, we should see, big and bold here, a field that is usable by the user to enter some location, but we have not implemented the following code. So we have only gotten the location out of the event. Now the next thing we want to do is to resolve this location to an actual geographic location. So this will be the next exercise. By the way, here in the XML view, we have also added some attribution to the weather service, which is required by the license. All right, now let's go to exercise 4. So in exercise 4, we will learn something new, how to use third-party packages from NPM. So NPM is a rich source of all kinds of helper libraries doing certain things. And in Node applications, it's totally common that you find what library is doing something. They just NPM install some library to your application and then use it. And you can now do the same also in UI5 applications, even though they run not in a Node server, but in the browser on client side. You can basically, as you're writing the code, do the same thing. You have to be a bit careful though, because some of those libraries rely on the Node environment. So they are doing all kinds of calls to all kinds of Node.js parts, and this is not something that can happen in the browser, obviously, because the browser doesn't have this Node.js environment. So some of the libraries work, some don't. If they are written really for the front end, they definitely work. It doesn't depend on in which module definition way they are written, because we are sort of wrapping them as UI5 modules. And this is all happening under the hood. So you just npm install a library, import it with the ES6 imports, and then it works just like you used to do it in Node applications. And the thing that is supporting this is an additional UI5 build tools plugin. That's the UI5 tooling modules middleware. So this is something you have to install also from npm, because we anyway have to restart later on the UI5 server. We can interrupt it here. npm install UI5 tooling modules and save it as dev dependency. So this is the tool that will wrap the npm libraries that we are loading and make sure they are available at runtime in the browser. And then we also want to use this, of course. And to do so, we go to the UI5 YAML file and add this task as the first custom task to the section. So this has to do with the execution order. We need to put it in the first place. So this is the list in the builder. There's the list of tasks. And this first entry, now be careful about the indentation, because in YAML files this is significant. So it needs to be aligned with the other task here, and those need to be indented one step. We add the tooling modules task here after replace version, and do the same for the middleware. So the task is for when UI5 builds the application into the dist folder, and the middleware is for your development when you're looking at it in the browser. So that's the live serving, so to say. Again, put it here as first one. One thing that I've not mentioned yet, the edge namespace. Make sure that this third-party library is put into a third-party folder and is added in a way that no resource nodes roots mapping is needed, and that the library is also included in the preload bundle of the application. So it's as integrated as possible, so to say. Okay, now this was the necessary setup to consume third-party libraries from NPM. Now let's do it. So what we are now using is a third-party library called Nominatim client from NPM. It's using the Nominatim service from OpenStreetMap, which is basically resolving strings to geographic locations. And this is one of the third-party libraries doing so. And because we just want to use that and don't want to write code to call the service on our own, checking what is exactly the syntax and so on, we are using this as a third-party library. So we say npm install Nominatim client and save it as dev dependency. It's used at runtime actually, but sufficient as dev dependency because the UI5 tools will make sure that it's available at the runtime. So this puts this client into the node modules folder. And if you now restart the npm start, the UI5 build tools, then we can actually check whether this code of the library is available. By just opening this URL. So if you go to localhost, resources, Nominatim client, then we see the code of this Nominatim library here. There's one thing, now we are using UI5 from localhost. If we are using UI5 from the CDN, so from a cloud server, from SDK openui5.org, for example, then this would fail because any resources by default loaded below the UI5 location and then resources. So it would basically try to find the Nominatim client JavaScript on SDK openui5.org, where it of course not is available. So in one file we have not looked at so far, in index.cdn, we need to make a small change. Let me quickly explain what these files are about. So by default, we are working with the index.html file here. You see this when we are opening the application, so that's index.html. And there UI5 is loaded locally from the same server, and the UI5 build tools make sure that UI5 is available there. You can, for example, in productive applications, also choose to load UI5 from the distributed content delivery network. And if doing so, it would load Nominatim client from there, which is, as I said, not available. But we can extend the resource routes. By default, they are already saying, yeah, well, the application resources are not there, but they are directly in the directory which we are working with. We can just extend the resource routes to also say, well, the Nominatim client also is not at openui5.org, but rather also available locally, not on that server, but on localhost in this example. So this is only relevant if you're using the index.cdn HTML, which you can of course do. But I wanted to mention it to make sure that you don't get into trouble when you are using UI5 from somewhere else. Yeah, here that's a wide mixture of quotes and commas, and make sure to get them right. Best copy the entire block. Okay, now the time has come to really use this third-party library. I use the Nominatim client in the controller. The first thing we do is import it like you would do in a Node application, go to the controller again, to the top of the file. We don't need the input anymore, it's grayed out. So I'll just replace that. So from Nominatim client, we import everything as Nominatim. And now we want to use it. So we go to the location change method, which has already retrieved the user input. Now we want to use the Nominatim client to ask for the actual coordinates. So we go here to the location change, Nominatim, and if I press a dot, I already get suggestion to call create client. And apparently this is not just something the IDE has made up, but it sounds like something real. And you see here, TypeScript already knows the Nominatim client and what methods and APIs it has. And this is great, this is like magic. You just imported it and it's everything there. And this is because Nominatim comes with the type definitions included. So even though it's basically a JavaScript library, there are type definitions included. For some libraries, the type definitions are not included in a way that you immediately get the type safety for them. But you have to get the type definitions yourself. So there's something called definitelytyped.org, which is a huge database of type definitions for JavaScript libraries. And for many libraries that do not come with their own types, you will find the type definitions there. So if this doesn't work right away, there's the second chance you have to have type safety. And those are then the ones on definitely typed, are the ones that are provided at NPM in the add types namespace. Like I mentioned in the very beginning, also the UI5 types, the OpenUI5 types are also offered at types/OpenUI5 via this definitely typed service. Okay, now we complete the code here. That's quite a bit of code, so I'll copy it and paste it all together. There are one or two things we have to import. The message box is not known yet, but with a quick fix we can get this sub message box imported, and most errors are gone. So what it's doing, it's creating a client with a user agent referrer. They are sort of required by the terms of use, and then putting the location that the user has entered into a search query. And on the results, you see how the results are typed here. That's the search result item structure and an array of it. On the results, we check if there are several results. So if you type a name like Newtown, then there will be probably several results. When there are several ones, then we just pick the first one. So we just take results. Oh. If there's no result at all, then we bring up a message box and say, well, the location has not been found. And yeah, then the user has to try again. Some news, if you have used UI5 with TypeScript before, now the enums, like action close, action something else, are now properties on the default export of a module. So message box, if it has an enum, then you don't import action from message box at the top anymore, but you say message box.action. So they are properties on the default export, on the module itself, so to say. Okay, one more error is left here. The display name, I've talked about that before. So the location that is actually resolved is also given as a string, so we can read it. And we want to display it in the UI. We have prepared it already, but the load weather data only has 2 parameters so far, so TypeScript tells us, well, there's no third one. You wouldn't also see this in JavaScript, but now we are reminded, okay, we go to the load weather data, just control click and you are there, and add the third parameter here. So we say as third parameter, place name is by default Waldorf. if it's not given. And the one thing we are adding here is after we got the JSON data, which was the weather information, we are doing a sort of hacky thing. We are just injecting the place name also as a property into the weather data structure. And of course, TypeScript notices, hey, you're doing something that was weather info. It was not something that has a place name. Yeah, right. I'm sure the quick fix here is, I don't think very helpful. We just go to the weather info and say, well, yes, it also has a place name. I have to look up the correct way to write it, place name. And it's a string, don't forget the comma or semicolon at the end. So now we have told TypeScript that the weather info can also carry a place name. And if you're now putting the place name also in the structure, then it also ends up in the model together with the weather data, and we can bind it to the UI, which we have actually already done. So this is how this place name comes now into the model. And yeah, as I mentioned, it's a bit hacky to put data from some source to some other data structure. You could override one with the other, for example, if you get new weather data and don't update the place name, but we're doing it all in one place here, so it should be fine for this simple example. So we have added the place name, and basically this should be everything we need to do for exercise 4. So the server is already started. Let's go to the application. We see the place name Waldorf is now given, the default value of the third parameter. Now let's enter a different location like Palo Alto. Okay. Now we have the weather for Palo Alto in Santa Clara County in California. Yeah, that's German. And yeah, that's the right one. That's Palo Alto we were interested in. Actually, it's pretty cool there. But of course, it's also at night right now. We have about noon in Germany. So that's the night temperature. Almost no wind. And yeah, so now the user can check for different locations. Like I like this one because it's always hot there. Test, that's somewhere in Iran, has 35 degrees. Yeah, so basically now the weather app has been sort of completed regarding the user input. The user can now ask for the weather in any location of their choice. And that's it with exercise 4. Now get to exercise 5, where we will create a custom control displaying the wind direction. Now, exercise 5. The wind direction was given as a degrees value, which is not looking very intuitive. You don't really know where the wind is blowing. So we want to replace it with an arrow that is showing, like you know it from all the weather maps, that is showing in which direction the wind is blowing. And we'll implement a custom control for it that is very, very simple. So in the web app folder, next to the controller folder, also add a control folder. The best thing is to select the weather app and then add folder. Then it's going right inside. So make sure it's at the right level. Control. And inside this control folder, create a file called winddirection.ts, not JSTS, we're writing JavaScript, TypeScript. Winddirection.ts. And inside this file, let's best paste the entire code of the control, and I'll go through it line by line, more or less. It's a very simple control. What you see in the beginning is first some imports again. So the controls are not written in a different way than the controllers. You have the ES6 module imports and you have the class definition in an ES6 way. So we inherit from the class control, the UI5 base class for all controls. and call our class WindDirection. Something that is also relevant for the controllers, I have not mentioned it there, you have to give the namespace, because when it's transpiled later on to JavaScript, when we have the traditional control.extend call, then we need to have the namespace for the UI5 controller, and this is only added when you add it here. So this comment is really significant. Okay, so the WindDirection control has some properties, aggregations, events, and so on. It only has a property actually called direction, a floating number, floating point number, which gives the degrees in which direction the wind blows. And this is also written in some documentation here. And yeah, the direction in degrees from which the wind blows. So this is something that can be confusing. That's the internationally common definition, that the value 0 means wind blows from north to south. So it's not where it is blowing, but where it is blowing from. And for TypeScript, the significant part here is how you define the metadata. So the metadata block that you have in all your 5 controls you develop is in TypeScript, or in this ES6 syntax, is a static read-only member of the control, and you can type it as metadata options. So we have given a type metadata options that was wrong. That defines the structure of the UI5 control metadata. So you can see here, you could have aggregations or events and so on. So inheriting from this, or defining the type as metadata options, make sure you have also type safety for this entire structure here. If you don't do it, on the other hand, then you might run into trouble when somebody wants to inherit from your control, because when you don't give any type here, it still works for you. But this means that if you inherit, TypeScript will complain that certain properties you are giving are not also given in the inheriting class, but you don't want to give them, you inherit them. TypeScript doesn't understand that this is something that is inherited through the classes. So if you are an older version of UI5, you can also type it as an object, but since recently, like early 2023, I think, you can say metadata options. And there you have to make sure to pick the right ones. There are metadata options in the element class, which is the base class of control and of all controls, but there is also metadata options in component and in managed object and one more. And make sure to pick the right one, because otherwise you will have a different structure here. Okay, so now you have defined the API of the control. And the second thing we need is the renderer. The definition of the renderer is all standard. Yeah, all standard JavaScript basically, with the exception that we give the render manager here as a type. So TypeScript knows that's the render manager we are working on here. And also the control. So TypeScript knows it's a WindDirection control, the instance that is coming in here. We just render one div, some CSS. You could also put this out into a static CSS file that you also load, but yeah, for the sake of simplicity, we'll just write the style here for every instance of the control. The only thing that is dynamic in this renderer is actually the wind direction that we are making rotate the content of the control. And the content of the control is a Unicode arrow. So that's a certain Unicode character. It looks like an arrow, and we are making it a bit larger here. You see it double font size. And by default, it points to the right. And 0 degrees means the wind blows to the south. So it should be like this. So this is why we are adding 90 degrees to the wind direction that we are getting from the weather API. Okay. And that's the control. There's a TypeScript error that we'll come to later. First, we'll use the control in the UI so we see whether it works. So we go to the view, And first we add the namespace for the new custom control. It's in the com my.app control namespace. You'll find it here again, so that's the namespace we are using in UI5 here. In the main view, I just close those two files again. In the main view, we go to the section at the very top with all the namespaces and add this namespace for the custom control. We call it CC, so we write further down, we write CC wind direction. Okay, so let's add this just below the wind direction number we already have, so we can compare and check whether it's correct. So we have a 1, 2, 3, 4, 5th field here in the form that is saying wind visualization and displaying this arrow. It's also bound to the wind direction in the weather model. So this is the direction we are getting in, and we are getting finally in the renderer. Okay, so we have not changed the configuration of the UI5 build tool, so the application that is still running should already have reloaded, and here it is. So there's an arrow showing, you see how it's rotated when you select it. The arrow that is showing into the wind direction. So 284 degrees obviously means the wind is coming from west, a bit northy. And this is much easier to understand, right? If you go to the other places again, like in test, we have a wind from the south. And you see now almost 180 degrees means almost from the south. Okay. So we are done. This is a custom control. Not a lot of big magic for TypeScript. The only thing is to know how to write down the metadata here. This line is something to memorize. The rest is basically like you do custom controls in JavaScript. Without this tiny thing here, the direction. So property get direction does not exist on type wind direction. Type wind direction is the control we've just created, and TypeScript says there's no get direction. You can't get the direction from the control. And that's true. We have not implemented any get direction method here, right? And this is because the accessors for those properties and also aggregations, events, and so on, add aggregation, remove content, attach, change, and so on. All these methods are generated by UI5 at runtime, so TypeScript cannot know about them. And of course we have to do something about it because TypeScript needs to know, otherwise it will complain. And it will also not give us any type safety for the result. And you could of course write those types manually, so the get direction and set direction method is pretty easy, but when it comes to aggregations there are like 5 or 6 different methods. When it comes to events there are 3, but they have very complex signatures. You don't want to write that by hand. And this is why we from the UI5 team have implemented a tool called TS Interface Generator. You see the name here, which we provide at NPM. So this is a small tool that you can just have running while you're developing, and it looks at the files you're saving, and whenever there has been change, it checks whether there's something inheriting from managed objects. So for example, a control that defines metadata, that has properties, aggregations, and so on. And then this tool generates an additional file next to it, which contains the missing methods. So it basically does the same thing that UI5 does at runtime. It generates the getters and setters and so on, in a way that TypeScript understands that they are also available at runtime in the class. Let's just do it and have a look at the file. This will make it easier to understand. So we use this one. Stop. Oh, wrong one. Stop here. So npm install add UI5 TS Interface Generator as a dev dependency. We don't need it at runtime. And how you invoke it is, for example, like this. So it has a watch mode. That means it keeps running, and whenever a file is saved, it reacts. And this is, I think, the recommended way, even if you do just a one-time action to generate the files. Let's start the watch mode. It takes a second because it needs to load all the UI5 types, but actually it was pretty fast. And you have seen two things. I think there's some output we'll look at later. And then the errors have gone and a second file has appeared here. So next to the winDirection.ts file where we have developed the control, we have now a winDirection.gen.dts file, which is generated and contains type definitions. Let's have a look at the content of this file, which has been generated. So it declares the same module winDirection that we have in the other file. And this makes TypeScript merge the definitions here. And most importantly here, the interface winDirection has the same name as the class, as the control that we have developed. This is exactly how we tell TypeScript. This class also has these things here, not only what is written in the TypeScript code. And you see, you get here the documentation taken over now since a couple of releases, and get the getDirection method, which returns a number, and the setDirection method, which expects a number and returns the instance, so you can do chaining, like in all the control methods in UI5. And once this has happened, TypeScript automatically sees, okay, getDirection does exist. You get here, right, the documentation and the type number and so on. So now it's working perfectly fine. The only thing is related to these lines here and to the explanation that is given out by the tool. While most of the things can be just handled magically by creating this definition file and putting it next to it, the constructor of the control cannot be extended in this way. To extend the constructor, you really have to go into the class definition. And this tool does not want to make changes to code that you are also maintaining at the same time, so it would maybe override some of your changes, or it would clash when both try to edit at the same time. So for the constructors, there's one more thing to do manually. You only have to do it this once. You copy this block between begin and end. Oh, again. And put this into the class winDirection, into the control. For example, right at the beginning of the class definitions inside the class. You see something has happened below. It's working again, but it's not giving this method anymore. So it's checking automatically whether these lines are there. And when they are there, it doesn't bother you anymore. And these lines basically define the different constructor signatures. When you create a new winDirection control, you can, for all controls in UI5, you can define this object where you initialize certain properties or attach event handlers and so on. And this is defined in this winDirection settings interface here, which we have not looked at so far. This defines basically the object structure that you can pass in when calling the constructor. We only have one property, so it's pretty simple. But the lines you have to add here, they are basically just saying, okay, in the constructor you can have this and can also give an ID for the controller. Okay, but now we are really done. The control is there, we have seen it's working, and there are no TypeScript errors anymore. So that's basically how to develop a control in TypeScript. And with this, the exercise number 5 is also done. Now we get to exercise number 6, which is the last one, which is about testing. So, exercise 6, let's have a look first at the test files that are already there. So when you create the application from the UI5 template, then there's already a lot of tests set up there. There are Karma configuration files. Inside WebApp, there's a test folder, which has a unit and integration subfolder. So that's QUnit tests and OPA tests. And basically everything is already set up in a nice way. There's, for easier writing of the path to the different files, there's already a setup in tsconfig, which makes sure unit/something goes down into this directory. So you don't need to care about that, just if you wonder how these paths are resolved. So we have not run the test so far. Let's do it now. There's, for example, the npm test call, which does everything related to quality checks. So it first does the linting we have done before. And then it does a comma start with a comma test with a hidden browser, so a faceless browser that is now running, and which is doing certain tests. And we've seen there was something red, there's an error. I mean, we have developed all the time without adapting the test, so it's expected that not everything will still work. And this is exactly what we are doing now in this exercise. Instead of the faceless browser, which doesn't really show you what's happening, you can also use just npm run karma, which uses Chrome to execute the tests in a visible way. So this is what you can keep running while you're developing for test-driven development. This will basically be open and remain open and execute the tests whenever there have been changes. So you see something has already failed because it probably looked for stuff that was previously in the UI, but it's not anymore. But basically this is what you can keep running while you're developing in test-driven development, to always keep checking whether some change broke something or whether your test is now running green. So the first thing that was failing, well, let's also have a look at how you can run the tests manually. So if you just do npm start to run the application, then on this server there's, so to say, also these tests, these test pages are also available here, and you can launch them directly in a manual way, not run by Karma automatically, but just to check the test manually. So you can go to the subfolder unit tests.html. I forgot the test. Okay, finally. So this is how you can manually run the unit tests directly in the browser without running a test runner like Karma. And you see here the main controller class has a say hello method. That was the test. The say hello method was removed quite a while ago, so this is something we have to adapt now. So we can go to exercise 6.1, fixing the QUnit test. The QUnit test is here inside test unit controller, where it tests the main controller. And you see it already given by TypeScript here that the property say hello does not exist on type main. So main does not have a say hello method. So TypeScript tells you without running the test already that something is wrong here. And well, for example, we want to check whether the load weather data method is there. That's not a very reasonable test, but I mean, it's just for explaining stuff. And well, also adapt the comments. That's always important. And when we now go back to the unit tests, it has already reloaded, and the load weather data method is there. Now this test is green. And of course you can do more things, for example, test what the methods are actually doing, which is the whole point of tests. But the most important thing here in this tutorial is, of course, to tell you how this is done in TypeScript, not to tell you how to write tests. And TypeScript specific stuff here is basically just the setup. So you have at the top, as top entry point, you have your QUnit HTML page, which is loading the test suite. which is at runtime QUnit.js, not TS. This is something to take care of. And this test suite defines the test pages, which are basically the unit tests and the OPA tests. And the unit tests, which we have now just launched, have this unit test QUnit HTML, which most importantly loads the unit test QUnit module. And this is basically what we have here. And this is how all the tests, the unit tests are bundled. The first thing we have to do, because we load the test asynchronously, is to stop the auto start of QUnit. Then we'll import with a dynamic import all these test pages that we have for the main controller and for other controllers. You can just list them here. It's doing promise all, so it waits for all to be loaded. And then we say QUnit, okay, you can start. And by the way, the same thing is also happening for the OPA tests in the integration folder. The same structure here. We have also this promise all, where we have a list of all the journeys. So you would say comma, import the next one, and so on, to have all the journeys loaded. And the same QUnit auto start false, and then start it manually. Set up. Okay, and this is actually what we want to look at now, the OPA5 stuff. In this pages folder, we have the main page. And this is now doing some integration test stuff with a dialog button and a button in the dialog. And then assertion, I should see the dialog. And this is all no longer in the UI, so we have to replace it, of course, with something. And this is why we replace all the actions we have. That's up here. Replace all the actions we have with one action that is named I enter location Heidelberg. So we let the test enter something into the input field. The enter text is something we have to add as an import. And then the assertions. When we have entered the location Heidelberg, then delete all the assertions. Then I should see the location Heidelberg. So basically the control displaying the location should display Heidelberg somewhere inside. We have things to import again. So the first is UI5 element, add an import from sub UI core element, because the control we are getting here is a sub and text control, and when we are casting to it, well, okay, you see here a problem from TypeScript that the UI5 element and the type text don't really fit to each other. And this is because text is actually not a UI5 text control, but it's interface text, the textual content of an element or attribute, MDN reference. But that's basically the text from the browser DOM. So TypeScript does not only know the types we are giving them, but it also knows other types like the like HTML elements and text nodes in the browser DOM, and it assumes that text here is such one. And this is why we have to make clear that this text we are using here is actually a sub-M text, not a browser DOM text. We could have solved this also in a different way, but we wanted to demonstrate to you that such things happen, that the TypeScript compiler thinks that something is from the browser DOM, some type, but it's actually a thing that has the same name and is from the UI5 types. Once we have added the import text here, the TypeScript compiler knows that it's not the DOM text, but the UI5 sub and text control that we are meaning here. And with this typecast now, this is a typecast in these other brackets here. The getText method is picked up correctly from the UI5 types, and TypeScript compiler says, yeah, okay, that's something I understand, and that works fine. All right, so we have changed in this main page the actions and assertions, and now we also have to adapt the journey because it still used the previous methods, hello button and so on. And if we call, well, actually we don't need to change so much. Let's go into the hello journey. You see here also TypeScript notices already that in the main page those methods are not available anymore. So instead of the action I press the say hello with dialog button, we use the I enter location Heidelberg action. And from the assertions, we use the dot I should see the location Heidelberg. And now you see something that if you are very familiar with the OPA tests, then something might strike you as odd in this place. Because something looks different to traditional OPA tests. And that's that usually here the actions and assertions were on the when dot on the main page, and then the assertions on then dot on the main page. Now it's all together in one object, only the main page object, and you have the actions and assertions both on this object. And that's actually a change we have made for the OPA test in TypeScript, or that we suggest, let's say. We don't use the given, when, then as arguments anymore that are passed in here, but we are loading the pages in journeys just as a class from somewhere. So we load a resource that has all the actions and assertions together on one object. And this is just a suggestion how to make it as easy as possible and as simple as possible writing tests. If you still insist on having the given and when and then, you can also still inherit, well, create a class, expose the methods there. In the testing branch of the TypeScript Hello World application sample, we have such an example where how this could be done. But basically for TypeScript, we suggest to do it in this way. Just define the methods, the actions and assertions on a certain object. You can name them appropriately so they are easy to tell apart. But it's much easier to use. You don't need to define them somewhere else and pass them over to OPA, and OPA passes them back to you here as when and then, but just load the object and call the methods there. So that's just a simplification that makes everything much easier. Right, so you get the enter location Heidelberg, and when this happens, then I should see location Heidelberg. And should see the location Heidelberg or so. Let's copy this from here. I think the rest of the method can be unchanged. And yeah, sample Heidelberg journey maybe. And there are more tests that is stuff that we can just delete. So we have only one test that is checking this Heidelberg stuff. So if we now go back to the page, we could now change the URL we had before with the unit tests, but we can also use this npm start command just to show you also this, which directly opens the page we are interested in. So this is like a one-liner how you can run and open in the browser the OPA tests. If we just enter this one here, then it opens and starts the integration tests here, the OPA tests. And you have quickly seen something changed, the location changed. We can do it again. So wind direction changed a bit, and now it's Heidelberg. And the tests are green now. And as we've seen before, we can run single tests with a browser opening in Karma, or we can run in a faceless browser all the tests and even the linting together. So that's all configured in the Karma configuration files here. Base configurations, that's the framework and the browsers. The Chrome headless is then set in the continuous integration version of the configuration, which inherits from the other one. And this is then only running once and not staying active all the time. And there's one more that is also using code coverage check. So there's some configuration for the code coverage reporting. That's something we can have a look at now. So if we run npm test, then this is exactly what's running. That's the Karma CI Conf version, which we can see here. So first we run the linting, and then the code coverage, including test of everything, unit tests and OPA tests. And as a result, once the tests are finished, we have run it before, you will get the coverage folder, in which you also get the code coverage output that you get here, but in a much more readable and nice way where you can look at everything. So let's do it in the report HTML directory below coverage. You can open the index.html file. You might not have this nice open in default browser thing. This is an extension in VS Code, but you can just open this HTML file in Chrome. And then you can quickly have a look at the code coverage in the different directories and the different controls, and you can really see the TypeScript code with how often every line has been executed. So this is really a nice way to really see in TypeScript, not in the compiled JavaScript, the code coverage and how you can control it. If, in case you wonder, Karma, isn't that deprecated, no longer maintained? For the time being, in UI5, Karma is still what we use for test running. So there would be an exercise 6.4, which is an optional one where you create an additional unit test. But basically, I think I'll make the video shorter by not going through this again. The exercise is here in the GitHub repository. And this means that we have actually come to the end of the entire thing. So we are through the entire tutorial. What you have seen is not only now in this section the overall testing setup and writing QUnit and OPA tests and how they can be defined and structured, but also you have learned the entire way of creating UI5 applications in TypeScript, starting from scratch with the template from UI5, the TS app template, then doing some application coding stuff, then integrating a third-party library, creating your own custom control in TypeScript, and covering all the things with testing. So we think that has been a hopefully useful introduction to TypeScript app development for UI5, and that you have learned a lot. If something is missing, if there are comments or so, let us know below, or report an issue in this UI5 TypeScript tutorial repository at GitHub. We are very happy about any kind of feedback and would like to learn how we can do better. We might also extend this tutorial in the future, so this video might relate to an older version of the tutorial, but right now I think this is what we can give, which is totally up to date right now in 2023. And I think, yeah, that's it. Happy developing in TypeScript. See you.